Hello everyone, welcome to GGI Geospatial Solutions Training. Today we are going to talk about the camera system. So this is the content of this course. So we will talk about the camera basics. There are CMOS, lens type, focal length, and we will talk about the exposure parameters and the camera parameters. Okay, let's get started. So the first camera basics is CMOS. So nowadays, the digital cameras are mainly using CMOS as imaging sensors. So we're using optical lenses, convert the optical path onto CMOS, and we are using a shutter to control the exposure and ultimately obtain the photos. So, and in the right, I have listed different CMOS sensor from different drone or payloads, and let's see what's the size difference. So you can see there are CMOS from M30, Phantom 4RDK, Mavic 3 Enterprise, and payload X7. So you can see have different size. Of course, if you have a better size of CMOS, the better of the image. So as you can see on our smaller Syrian drone, Mavic 3E, compared to the Phantom 4RDK on the CMOS size, it has a larger CMOS. Okay, and we also have the 4-frame CMOS sensor from P1. It's a way large better. Okay, and I have attached two larger CMOS sensor from Hasselblad. Okay, with medium format. So on the CMOS area comparison, so you can see P1 is 28 times more than M30, and as for the Hasselblad H6D, so it's 69 times more than M30. So the CMOS size is very important. The larger the better. And there are also another parameters that will depend on the CMOS quality. So there are pixel size. Of course, the bigger the better. So the bigger the pixel size, the higher the tolerance. And as for the resolution, so under the premise of the equal pixels, the larger resolution, the better the details are presented. And as for the tolerance, okay, so it's the richness of information contained in photos. So the higher the value, the greater the speed for operability. And as for GSD, we have discussed in the previous course, so I will not give this detail. Okay, another parameter is the lens type. So the principle of lensing imaging is focus light on CMOS. So the interior of the lens is composed of multiple sets of lenses. So we can also divide it into several types based on whether the focal length is variable and the focal length range. So there are fixed focus, zoom, wide angle, and telephoto. So since we have talked about the focal length, and what is the focal length? So it's the distance from optical center to CMOS. Okay, I have attached the picture in the right, so we can see the difference. So the longer of the focal length, so please follow my mouse. So the longer of the focal length, so it means the narrower of the field of view, and the higher the resolution, and we can see more details. Okay, and on the optical side, so the shorter of the focal length, so we will have a larger of the field of view. Okay, and the lower the resolution. In this way, we can see the whole picture clearly. So I have also attached 4 different pictures with different focal lengths. So first, let's see with 28 millimeters. So absolutely is a shorter focal length, and we have a larger view. We can have a better view of the entire environment. But with the focal length rising, so we will get narrower and narrower of the field of view, but we will get more details. And there's another word called the equivalent focal length, which means the focal length remains unchanged, which will bring us the lightweight and with better imaging. And as for the relationship between FOV and CMOS, so usually the visual field of view use 50 degrees and visual proximity. And the full frame 50 millimeter as the standard. So I have also attached a difference between the full frame and half frame. Okay, next part, let's discuss the exposure parameters. So to capture photos with normal exposure during field flights and minimize the motion blur, it's necessary to adjust the camera exposure parameters. So underexposure or overexposure of photos can affect the imaging quality, and the exposure is determined by a combination of these three parameters. There is aperture, shutter speed, and the ISO sensitivity. Okay, let's go through them one by one. First one is aperture. So the aperture controls the area of light projected onto the photosensitive element. It is represented by f plus numbers such as f4, f8, f16, and so on. So I have attached a comparison between different aperture and with different effect. So let's see. So the smaller of the number, for example, f2.8, so it means the larger of the aperture. So the more luminous flux and the brighter of the image. And on the opposite side, with the number rising, so actually is represented a smaller aperture. You will get a darker photo. And there's another word we call the depth of field. So it means the larger the aperture, the shallower of the depth of field. So objects at a long distance will blur. So let's see a comparison between the larger aperture and the smaller aperture. Okay, so with a larger aperture, the photo scene is shallow. So both the front and the background are blurred. So see, it's very obvious. And with the smaller aperture, the photo scene is deep, so the entire picture is very clearly. So there's another parameter called shutter. So the shutter, it controls the time when the light is projected onto the photo element. So it will expressed in seconds, such as the number, for example, 1 second, 1/10 seconds, 150 seconds, etc. So I have attached a comparison between different numbers of the shutter. So as you can see, with the shutter speed rising, so the longer of the shutter time, the more light passes through and the brighter of the image. Right, it's very obvious. Okay, and as for the longer of the exposure time, so the brighter of the image, but the blurry of the moving object. So if we have the shorter of the exposure time, the dimmer of the image, but we will get a clearly image on the moving object. So there's a question. So in our aerial surveying, so the drone is flying very high speed. So what exposure time or what shutter should we use? Should we use the smaller one or the larger one? Okay, please consider this. And I will also attach the different speed to represent the faster shutter speed, medium, and the slower shutter speed. So just for you to better understand this. And since I have raised the question, so next page is the answer. Okay, there's a word called safe shutter time. So during the aerial surveying flight, the drone is moving at a very high speed. For example, for the Mavic 3E, it can reach to 15 meters per second. So the photo taken are prone to be blurry and deformation. So which will bring us easy to bring us the jello effect. It means the photo is significantly distorted and deformed. So it will significantly impact on our surveying and mapping accuracy. So to help you better understand what is jello effect, so I have attached two pictures. So you can see in the left pictures is taken by electronic shutter at a very high speed. You can see the rooftop is blurred and not sharp. All the details are blurred. So this means we met a jello effect. So to avoid this and to get a clearly and sharp image, so we switch to mechanical shutter, even at a very high speed. So you can see we will still get a very clear image with very detailed information. So definitely we should use the mechanical shutter. And for my previous question, so definitely we should use the smaller shutter time, right, to capture the picture very quickly, to be sure that there's no jello effect. And there's as for the value of the motion blur, so it will equal to the shutter time minus the flight speed. But to ensure a good accuracy, so in general, the motion blur usually should less than half GSD. So it means our safety shutter time minus the flying speed should less than half GSD. So next time when you go to carry out a field surveying, so please follow this formula. Another is the ISO sensitivity. So it refers to the sensitivity of a camera's photosensitive components to light. So it will be represented by ISO plus numbers, such as ISO 100, ISO 800, or ISO 8000. All right. So I have attached a comparison between different ISO or different pictures. So as you can see, the larger the number, ISO number, the more sensitive the camera is to light, it will result in a brighter image. Okay, let's make a summary of this part. So we can adjusting these three parameters every time when we taking a photo, but it will reduce our efficiency. Okay, so automated exposure can be selected, and the exposure compensation can be adjusted according to the brightness of the screen to obtain a proximity exposure. So also I have listed the relationship between aperture, shutter, and ISO in different situations, just for you to better understand this. So if you have questions, please go with this picture, so it will give you a better answer. Okay, next part, let's discuss the camera parameters. So first is the focus. So it's the process using a camera focusing mechanical to change the distance or position and the position of the object being photographed. So in order to achieve a clear imaging, so it's called the focusing. So when we're using the photogrammetry mode for aerial surveying works, the camera will automatically focus to infinity, so without the need for further focusing operation. Okay. Another parameter is the image destination. So in order to achieve better imaging results, so a lens is added in front of the camera lens, so which makes the light rod, it will no longer following the pinhole imaging model, which will cause the image distortion, so as shown in the left pages. Okay, so when we do the reconstruction, the model in DJI Terra, so it will intelligently extract the factory calibrated destination parameters from the photo XMP information, then can correct the destination of the image. So thereby it will improving the accuracy of the model and to raise the efficiency. Okay, thanks for listening this course of the camera. So hoping this course will helpful for you. And let's continue meeting you in other courses. Okay, see you. Bye.